Welcome to Microsoft Excel with EJD. In this video, we'll be looking at solver for what if analysis in Excel. From the idea of the phrase what if analysis, that means you're saying, okay, I have this situation. What if the situation changes to this? What is going to happen? That is exactly what if analysis is about. And so far, we've looked at doing what if analysis using a scenario manager where you create different scenarios to visualize the possibilities you can have, right? And then in the last video, we talked about goal seek, where you can work towards an expected end, where you can work towards a goal by changing something. That's talking about goal seek. Now, but the disadvantage of goal seek is that it is only for one variable. You can only change one variable to achieve your goal. But for solver you can change more than one variable at the same time, and that's exactly why we are looking at this right now. So, introduction to solver in Excel solver is an okay. I mean, introduction to Solver in Excel, right? Solver is an advanced optimization tool in Microsoft Excel that allows users to perform powerful what if analysis. Unlike goal seek, which we saw in the last video, right? Which changes only one variable to reach a target. Solver can change multiple variables to find the optimal solution for a formula in one cell, subject to constraints on the values of other formula cells or variables. So here, solver can even take care of constraints if you have limitations and you cannot go above a particular level. So solver can do that for you, or you cannot go below a particular thing. Anytime you have a constraint like that, solver is your go-to instead of goal seek. So solver is commonly used for optimization problems, e.g. maximizing profit or minimizing cost. If I have a whole playlist on linear programming where we used Python all the way. So finally, our time has come. In the next video, I'll be using solver for linear programming. But for now, it's this what we are doing here is, you know, so it's more or less like linear programming too, but it doesn't always have to be linear, because we have three solvers in Excel, yeah, and part of it is simplex for linear programming, and then we have other ones. We have like evolutionary for cases where you have multiple maximums or multiple maxima or multiple minima, and then you also have uh, another one which is for maybe something that is not a linear stuff, and but it is not multiple like that, maybe just a curve like that. So solver is commonly used for decision-making scenarios, also resource allocation, scheduling and planning, linear and non-linear programming. So talking about the components of a solver model in Excel includes the following components: as an objective cell, as you're going to see very soon, the target formula you want to optimize, whether maximize, minimize, or set to a specific value, and it has variable cells, decision variables. So the cell solver changes to optimize the objective, and then it has constraints too. So you have rules or limits applied to the variable or other related cells, e.g. must be non-negative, integer only, or within a range. So if you want just strictly integers, you need to pay attention to all of these limitations, right? So yeah, I was talking about different solvers in Excel just now. So there are solver solving methods, and these are Excel solver offers three solving methods, right? You have simplex, for linear problems, and you have GRG non-linear for smooth non-linear problems, and you have evolutionary for non-smooth complex models, e.g. genetic algorithms. I think I've also made mention of all these evolutionary methods under numerical optimization techniques. So you need to choose based on the structure of your model. So you need to know whether you're solving a linear problem or a smooth non-linear problem or a non-smooth complex model. So if you're solving linear problem, of course, simplex is your go-to. If you're solving smooth non-linear, you're doing like maybe you're solving a quadratic equation or something like that, you may go for GRG. And then evolutionary, if you have like maybe a cubic, quartic, and all of that, you can go for evolutionary. So use cases for solver and what if analysis, right? It's used for finance, like portfolio optimization, loan amortization, budgeting, operations like supply chain optimization, inventory planning, in marketing like mix modeling, campaign allocation, for project management, for resource leveling, timeline optimization, and manufacturing, so where you can have product mix, machine scheduling. So, and of course, when you talk about differences between goal seek and solver, for feature, talking about variables, In goal seek, you have only one, but for solver it can be multiple. Objective, you have a set value in goal seek, but in solver you have to either maximize, minimize, or to a set or set a value. Constraint, no constraint for goal seek, but there's constraint for support, which supports multiple constraints in solver. Then for use cases, goal seek is good for simple target analysis. You have a target, you want to work towards it. Solver is good for complex optimization and planning, as you're going to see in a jiffy. So some limitations and tips. Solver may not always find a feasible solution, especially with nonlinear models. But you need to ensure your formulas are accurate and continuous if using GRG, and using sensitivity reports for deeper what if analysis, deeper what if insight, available only for linear problems. So we are going to see that when we do linear problem in the next video after this one, then you can save a backup of your model before solving in case you want to revert. For goal seek, we cannot revert. Once you do it, it's done. But the only thing is that it's very easy to implement in the first place. So you can reverse, you can undo and do and go and check other scenarios. So in conclusion, right, Solver is a powerful what if analysis tool in Excel that allows for multivariable decision making under constraints. It empowers users to go beyond basic forecasting by simulating and optimizing real world scenarios, making it essential for anyone involved in planning, analysis, or strategic decision making. Now that we have told all the stories, let's go into something practical. So I'm using this Excel sheet where I have this profit scenario. So imagine I make five products, you know, and I make five products, right? And I want to get the number of products I should really produce so that I can get the highest profit. Of course, that's why we all do business for sure. So imagine. So first of all, I've not done any formatting, like any. Okay, I've just started formatting, right? So, but then I have a constraint. Maybe the products are they require the same kind of machine or whatever, and I can only make 3,450 of those products. So, and the profit I make for from the first product is $120. From the second, it's 125. From the third, it's $150. From product D, it's $135. From product E, it's $125, right? So the question is, what quantity of each of these products should I actually produce so I can make the highest total profit that we are going to have here? So first of all, if I want to get the product profit, what I mean by product profit is when I sell all the products, what is the profit I'm going to get? So that's simply going to be this, the whatever quantity I produce there multiplied by the profit I get from that. So that'll be zero for starters because I really don't have anything for those. So I can just drag this down for the rest as usual. Just drag this down. So let's see if the formula is correct. Here we have B3, C3, yeah. Here we have C3, C3, C4, right? C3. Okay, B4. Yeah. First of all, this is B2C2. This is B2C2. Here, this is B3C3. So B3C3, B4C4, B5C5, B6C6. And then we can do the total. That is just the summation of all of these profits. Now from here down to this place. Okay, and I just press enter. So everything is zero for now because we have not really made anything, we have not made any scenario thing like that now. So we have just set, it's more like we are ready, okay? But then we have constraints. Number one, the products we are producing, we probably want to make sure that they are all whole numbers because probably if it's like a car, we can be talking about like half a car. By the way, when you want to talk about solve, right? It comes to data, and if you look up here, you see solver. Now, not everybody will have this solver thing. If you don't have solver, the way to put it up is go to file, click on options, and when you come to options, you're going to find add-ins. So under add-ins, then you look for X. You see this Excel add-ins. You click on go. So when you click on go, then you now come for solver add-in, and then you click OK. So if you did not have it before, it now shows up here. So that's the way to have your solver. So it's an add-on. It's an add-in rather that you need to install yourself. You need to activate, so to speak. So if you don't have solver here, just follow what I did. File, options, right? Then add-ins. Then you see Excel add-ins. There are different types of add-ins, but I'll focus on Excel add-ins. Then you click on go, and then you do solver add-in and say okay, and then your solver is now activated. So you can now begin to use your solver. Now that this whole thing is set up, we want to know how many of each of these products should we make so that we can meet our target, right? Um, in fact, we can even add demand, right? Let's say what maybe we have some demands for each of these products, right? Uh, we have some demands for them. All right. Let's also format this to be centralized, right? So let's say that people are demanding for three let's say for 200 let's say for yeah let's say people are demanding for 300 of product A, they are demanding for 500 of products B, they are demanding for 400 of product C, you know, they are demanding for say okay, yeah, let me just assign that randomly. Maybe they are demanding for 250 of product D, and they're demanding for say um something random to 450 of product D. So you can see there we can also have like total demand, right? So we have the total demand here. Let's just try to sum that up. Uh, total demand, total demand. So I can do a text wrap for that so that it doesn't spill over. So I just say wrap text. So it just extends down instead of having to extend that. So I do this and this is B, right? So total demand is just equal to, you know, this sum, okay, sum of this from here down to here, and we have that. So okay, 1,900 demands. No, 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 no. Let's do it something that's more than this. So let's say this is 700 now, all right? And let's say this is 950. The people want 950 of this, and let's say people want 7,550 of this. All right. That's 10,000. Okay, that's okay, let's say 755, right? 755. Okay, good. So this 3345. Let's say people want like 5675 of this now. Okay. So now we have a demand for okay, we can even raise it like 680, right? Of product B. And let's say people need 1,050 of this, right? So this is what we have right here. So imagine this situation. So clearly the demand is more than our capacity for production. So there are many things you have to consider in this kind of scenario. First of all, you don't want to produce more than the demand. So whatever happens, you don't want to produce more than 700 so that you don't have a waste. You don't want to produce more than one. You don't want to produce more than 700 of product A. That is, you don't want to produce more than 680 of product B. No matter what, you don't want to produce more than 1,050 of product C, and so on and so forth. So basically, um, so even without using this solver thing, you want to look at what gives you the biggest profits, right? For sure, product C gives you the biggest profits. And if possible, the demand is 1,050. So you naturally just want to produce all the 1,050. All right. So that way you have 157,500 total profit just from one product, right? But thankfully, you still have capacity to make more. So after doing 1,050, maybe the next thing you want to go for, you look for the next profitable venture. Okay, yeah, this is what we look for it. So you look for the next profitable venture, which is 135, right? So 135 product D gives you 135 each. So, and you have 755 demands. So you literally just want to assign 755 to that. And there you have this. So um, thankfully you still have we met the quota? Okay, let me even try to do a kind of total for this. So we can visualize what's happening real time. So I have sum, open the bracket, from this down to the last here, and I press enter. So we have 1805. Good. So we can still go for 340. So now that you have assigned all the goods for $135, right? Now, this is a manual way of answering this question. That is like a logical, commonsensical way of doing it. But it may not be this easy to do all the time. So having taken care of the top two products, maybe you now want to look for the next profitable, which is product A. So for product A, there is demand for 700. So we can assign 700. All right. So you can see the profit is making sense. After 700, we want to go to for the next profitable venture, which is 680, and this that requires. So we still have capacity that requires 680. So we can put 680 here. All right. If we put 680, wow, we are still good. That's 3185. We can assign all of that, and then what's next? Maybe we now have so the last one now. If you do 675, that will be too much. So that is so we can't carry this. So it means we can still manufacture some of this 675, but we can't do everything. So we just balance it up, like whatever is left for this. So it means we can nearly produce all these products. Uh, okay, let me do this now. Let me just do a quick math. So let me just say, um, let me remove this now. So let's just say is equal to this now minus this. So we can know the balance minus B7. So we need, so it means the only thing we can do is to produce 265 of this. That's the only way we can go. So with this now, this is the maximum profit you can have of 461,550 by producing 700 of product A, 680 of B, 1050 of product C, and 755 of product D, and 265 of product E. So that's a very logical way of going about this. But then that's not our purpose here, right? So we want to use want to use solve to take care of this. But if you want to do it logically, you start from the highest profit and keep going like that. So let's see what solve will do for us. So let's go to data again. So we go for data and we click on solver. So for the solver, so the first thing is our objective is about this profit, right? So we want to set this total profit. We want to make it maximum. But or if you have a particular goal in mind, you can say value of, so you now fix the value you want. But maximum is fine based on what we have. So what variables do you want to change? So you come here, you want to change the quantity of production. Here, you just highlight all that at once. That's B2 to B6. So the next thing is you want to add constraints. So what possible constraint can you add? Number one, you want all the quantity produced to be whole numbers. So you have add. So what are you adding? So all the quantity produced, right? Let's see. Yeah, we have something like integer. Very good. So all the quantity produced, right? All this uh so you click here. So all this quantity produced, first of all, they must all be integers. Okay? They must all be integers. Then you add that. Okay? So the next thing is that since they must all be integers, but integers can also be they don't have to be they have to be non-negative, but well, I think we're going to take care of that later. Which other constraints do we have? First of all, the sum, the total of, okay, I think I need to come back here and do that something. Mm, okay, I think I should have done that sum before. Okay. What do I do now? What do I do? What do I do? Yes, let me come this way because that's a very legitimate constraint. Okay, let me do that summation. So let's close this first. Whatever you have saved is already there, so no worries. So we say the total product here is equal to sum of B2 to B6, right? B2 to B6, enter. So whatever happens, okay, we go back to our solver now. Whatever you had there, you can see everything is still there. So this total quantity now cannot exceed 3,450. So in this case now we need to add another constraint and say that this B7, all right, this place must be less than or equal to uh, this 3450, right? It must be less than or equal to that. So we add that again. Oh, okay. I think it's added already. So we add that again. So let me close this and go back. So you can see you can B7 is less than or equal to B8. That's another constraint. What else do we have to do? Um, okay. What else do we have to do? What else do we have to do? I think we are good to go. Yes, I think we still have another level of constraints now. Another constraint is that all the products we produce. Okay, we have said they must be integer, right? Another layer is we want to add another integer to say that all these guys, all these things you're producing, all right, all of them like that should be also less than or equal to the demands because we don't want them to exceed the demands, right? So we have, oh, okay, I think all right. So all this, each quantity produced, right, must not exceed the demand because we don't want wastages. So they should be less than or equal to all these demands. And once that is done, you add it again, and then you can say, okay, yeah, okay. So now we're back. I think all our constraints are in order now. Now, so here you look at the possible solvers. You have GRG solver. It tells you that select the GRG nonlinear engine for solver problems that are smooth nonlinear. Select the LP simplex engine for linear solver problems, and select the evolutionary engine for solver problems that are not smooth. Now, in this case, I can't really place. I can assume that this is linear programming, but I'm not sure. So, but to be on the safe side, I can use GRG nonlinear because it can handle not linear and non-linear problems too. So, and it is set there by default. So that tells you something about that. So now that you have set everything in place, the objective is about this total profit, which is F7, I believe. And then the variables you want to change are the quantity produced. So take note of what I did manually before and compare it with the results you're going to get now. So once all of that is done, you just click on solve. And once you click on solve, it tells you, do you want to keep your solver or you want to restore original values? So we want to keep our solver because the original value had nothing there before. So I just click on OK and we just get our answer like this. So it tells you that just like what we did before, right? You need to produce 290 of uh oh, okay. So okay, I think the result is different from what we did before. Yeah. So it tells you that the best profit you can make is to produce. Oh, okay, I think it's the same. 1050 of the highest one, 680 for one for this, and you just go on like that. I think the number of products for 675 is a bit different. I don't remember what we got the other time, but you can compare that and this. So, but based on this one now, the total profit, I'm not sure what we got the other time. So now the total profit is going to be $463,600, right? So based on what the solver is giving us. So that is one thing about this now. So if you go back to the solver, right, you can see, okay, let me do the solver thing again. So if you want a report of the answer, so you can just click on OK and it gives you a report page. So you can click on the report and then it tells you all these details about how it should go. Solution time it took is 0.031 seconds and all the so which of the how should you produce those things to get what you have. So this A is not binding, meaning that anything that is zero, right? I mean, these are things in linear programming, for instance, that you can think about. So anything that has zero doesn't really matter, but this one that is not binding, you have this 4.410 slack. I think I'm not too sure about the implication of that right now. But this binding and non-binding has an implication. So that's how you can actually solve this. But of course, if you're going following the logic, right? So you can see 290 against 700 demands. So of course, 1050 supplied for this, followed by all the 755 for this people. Then you go for 125, okay? 68. Oh, okay. I think I was wrong the other time because 125 and 125 are the same. So you should meet these demands first before you come to the least productive is 700. So I'm not sure what I did at that point, but I think this is better. So what I did manually the other time, I should have attended to 125 before coming to 120, but that's fine. So that's how this works. So you can see I was even making mistake with that simple. I was probably making mistake because the result I got was different. So you do 125, 125 because before you go for 120. So you can see the solver takes off that pressure of having to do it manually from you, and that's why it's highly recommended. So with this, we come to the end of this video on using solver for what if analysis, and this in a profit maximization situation. In the next video, we'll be using solver again to solve a linear programming problem. Or of course, I can still use linear programming in this case, right? So I just click on solver. So instead of using GRE, I just do this and go to simplex and I solve, right? So, and then it gives us a result. I think it gives us exactly the same result. So it doesn't make any difference. So GRG by default always works, So with this, I come to the end of this video. Let me know how helpful this is for you. And if there's something you like me to try out, feel free to let me know also. If you have not subscribed, please go ahead and subscribe and make sure to hit the notification bell so you can always get alerted each time a new video is released. You can become a member of my channel by clicking on join, and you see 3 levels of membership with the associated perks. You can be sure you're going to have a nice time if you're a member of this channel. I mean, if all you do is subscribe, also you've already been learning a lot already, so you still have that for sure. So don't forget to like this video, share, comment, so that more people can have access to the great content I have going on here. Till I come your way again, keep doing data right. Bye.